Hello. So I'm Fran, and I am a tech support person in the physics group. I've been here with Vernier for 9 years, and I am very excited to present this webinar. I'll just let Tom introduce himself as well, and then we'll get started.
So Tom Smith, also part of the tech support group, branching over into engineering and physics, and come to Vernier from teaching high school physics and engineering. Been with Vernier about 8 years now. Thanks, Fran.
Thanks, Tom. All right, so we're going to start off with basically we're going to have two parts to this webinar. The first part, I'm going to talk about getting great videos for doing video analysis, because if you're going to do video analysis, you want a video that's easy to analyze and will show what you want to show and will not be challenging for your students. And also having your students collect the video is definitely part of the fun and part of what gets students involved. And then Tom's going to do an example from our book, Video Analysis, Conservation Laws and Forces. Vernier Video Analysis, Conservation Laws and Forces. Missed the first word of the title there when I was reading off my little thing here. So the things I'm going to talk about are 5 basics. 1, stability. 2, light. 3, what's in the frame. 4, camera settings. And 5, editing. So we'll start with stability. If your camera's moving, and I'm assuming that most students are going to use their phones to collect video. If their phone is moving, you're not going to be able to analyze it well. So first of all, our suggestion is use a tripod. And this tripod has one of these doohickeys on it. So this is a thing that you can buy that lets you put this on a tripod, hold the phone. And if you don't have giant tripods like this one, which are expensive, especially if you want to get several of them for your classroom, there's also plenty of little tripods that will work as well. So this is one of those ones that can grip anywhere because it's got these bendy, but they're also pretty stiff, so you can also just stand it up. And you can get those for less than for one of the big ones. But even if you don't have tripods, there's also these things. You might have some of these lying around. This is a box. And a box, let's see, it'll still be in the frame. Yes, it will still be in the frame. You can take this, and especially if you've got something that's like down on the table, you can kind of put this up so that the camera is going to be looking down at the surface. And then your other physics classroom friend is tape. I love tape. I go through a lot of it. But you can pretty much put that right over the phone. It holds it in place. You can do this with other kinds of boxes and make things go kind of vertical. The only trick is you want to make sure that you have the record button available on your phone. So that's, boxes, tape. I love these things. As a last resort, physics textbooks. I know, physics textbooks are for making ramps, but they can also be used to support a phone. So, stability. No holding the phone in student hands if possible. All right, next, light. So here I am inside a room, and this room actually has giant windows in it, which is really nice for being in the room. But even so, and I'll show you this on camera settings as well, it's not going to be as good as actually going outside. So when we talk about camera settings, I'll actually demonstrate that with settings on my phone for going outside versus being inside. Now, sometimes you can't go outside. It's freezing cold out. It's snowing. It's raining. It's way too hot. Your next option is getting as much light as possible. So for getting as much light as possible, one thing I used to do was back in the day when we had overhead projectors, the big, overhead projectors with the box with the light in it, and then the thing with the lenses, and it would project it onto a screen. I would gather as many as I could from around the school and store them in a closet. And one or two of those provides a good bright light. It's not fluorescent, so it doesn't flicker, which is important if you're doing anything in slow-mo. And if you have multiples of them, then that's a lot of light. That is really good, and it's your next best to being outside. Now, you don't need a sunny day to be outside. I happen to have a sunny day outside here, but if you're in the shade or if it's a cloudy day, that's almost always going to still be brighter than indoors in your classroom with just the fluorescent lights. Surprising, but true. All right. Next, what's in the frame? Not much. As little as possible. Okay, so I have here a wall behind me. It is cinder block wall. Probably a lot of you have cinder block walls. A cinder block wall is okay. All right. Ideally, it would be a flat surface painted wall, because even a cinder block wall has these little lines on it, but this one's not bad because the mortar in here is almost exactly the same color as the cinder blocks themselves. So that's not bad. You also want a scale object. I have a ton of scale objects. This one's one of my favorites. It's a meter stick, and I put a piece of electrical tape every 10 centimeters. So even if it's from a distance, I've still got 10 centimeter marks. This can go great for up close things. I have a video, or we have a video in our Vernier Video Analysis Motion and Sports book, which is of a turntable. And there is one of these resting on the turntable, the box, not the part that spins, not the platter, the actual box. I'm terrible vocabulary today, sorry. So this is my friend, and I guard it jealously, and I'm always upset when it disappears. We also have this thing. This is also 1 meter, and it is a bright red piece of 2x4 with a dowel or piece of broomstick or something in it. And I can set this on the floor and it will be a 1 meter scale. We also have a bigger one of these for going out in the field, like literally for track and field. You'll actually see this in the video that we'll be working with later with Tom. And this is a 2 meter 2x4 painted red. So it's nice and bright, good contrast with grass and also with gray cinder block. And we know how long it is. It's okay that maybe it's not exactly 2.00 meters. That's not going to be enough of a pixel to make a difference when you're doing the analysis. Are there any questions? I keep seeing things showing up on the chat thing.
No, Fran, I think we're taking care of everything that shows up there. Somebody wanted to know if we were going to save the chat, so we'll make sure that they have that available to them.
All right, awesome. So as a last resort, if you're doing a person and the person is standing up straight, if you know how tall the person is, the person can be your scale. If you are doing a track in a cart, measure the cart, and that can be your scale. Ideally, the longer your scale object relative to the frame, the better, because that gives you a better scale to work with. Because if you're off by a pixel on a tiny measurement, that off by a pixel is going to propagate through that length. If you're off by a pixel on a giant measurement, then for smaller measurements, it'll be a smaller and smaller fraction of a pixel that you're off. I hope that makes sense. All right, what else is in the frame? Your object that you're videoing. And your object, ideally, is going to be the same distance from the camera as the scale object. So if I was doing this with the meter stick, I'd want the meter stick and the basketball to be the same distance from the camera. And here's why. As I move the meter stick closer and farther away, check out how that expands and contracts. So here I've got a really long meter stick that takes up the whole frame. And here I've got a short meter stick that probably takes up less than half the frame. And this is just with the length of my arm. And again, we'll talk about this in camera settings as well as to how to mitigate this. But ideally, you want the thing that is going to be marked in the video to be the same distance from the camera as your scale object. So one of the things that will help will be to get much farther away from the camera. But then we'll talk more about this in camera settings. Your moving object should be a different color than the background. So here I've got this basketball, it's orange. Here I've got this Nerf soccer ball, it's yellow. Both of these are pretty good against a cinder block background. And then I have this thing. This is a tiny little basketball, and it's sort of a speckled gray on one side and black on the other. And when I put that against the cinder block wall, notice that it's not that visible. This is a terrible thing to use as your object. So try to pick something with a contrasting color. What else goes in the frame? Well, sometimes the thing in your frame really is all the same color, or it's an extended object and you don't want to show, like, you don't want to look at the movement of all of it. So this is where we can get fun things like bright yellow stickers, which it's hard to tell when they're all over. But here I've got some bright yellow stickers that I can put different places on me. We did a video for our, and I'll come a little closer so you can see them a little bit better. We did a video for the conservation laws and forces on the bicep curl. So in that case, it's useful to have the locations of different parts of the body, specifically your elbow, that hinge point, you want that to not move. And then the other thing would be on the end of the barbell. I did not bring a barbell in here, silly me, just basketballs. But you can see how this makes it more visible. We also use tape. So for example, if I wanted to show my knee, I might put some tape on my knee. So tape, especially, this is, oh, I know I can do this. Especially if I'm gonna jump. You can see that. I'm not a good jumper, my apologies. And then finally, and here's where kids may start getting really into it, we can make it all video motion capture-y and start putting ping pong balls on your body. Ping pong balls can be bought in bulk at Amazon, and they're not great for actually playing ping pong, but they're good for this kind of thing. It's a really terrible ping pong ball for ping pong, but in terms of being a white thing that you can track, not bad. All right, and of course, kids will love wandering around the school wearing ping pong balls, and other students will see us like, why are you wearing ping pong balls? Why do you have ping pong balls stuck to you? Well, I'm in physics class. Great advertising for your physics class if kids are seen with these all over them. All right, camera settings. So here I'm going to share my screen, but first I have to get my, there we are, get my phone up. right, screen share. All right, so here's my screen, and I have this specifically so that you can see the app that I'm choosing, which is this one down here called Pro Movie. And I have an iPhone, and this is one that we've been using here at Vernier to collect iPhone videos. And you may have an Android phone that may have some other apps that you could do this. But the point of this is that this app will take control of your phone's camera and let you control it to a finer degree so that it's more like an SLR and less like a point and shoot. And I do not know all the functions on here, but we're going to talk about some of them. So first, let me open that, and it automatically goes like so. So let me put this on the tripod real quick. Ah, it disappeared. There we are. So let me put this on the tripod, making sure not to press the power button or the on-off button on the phone. So here it's on the tripod, and it's got a ton of settings. It's got settings on the left, it's got settings on the right. What am I doing here? So the first thing that I want to do is actually go to the settings, which is the gear, and it lets me choose things like selfie. So now I can actually face you while I'm doing this, and you guys also have all this other screen, so you can't actually see my face. But there's also other options here. So this will depend on the camera on your phone. Different phones have different cameras, but this can tell that this iPhone has 3 cameras. So I can go back, triple, ultra wide, wide, and telephoto. If possible, always use telephoto. So this is what I was talking about with the settings, right? So with the settings, the reason that you want telephoto is telephoto basically flattens the scene. And I was moving the meter stick, closer and farther away, and you could see the shrinkage. If you're using a telephoto lens, that motion is going to change the size of your objects much less. So something that's closer to the camera is going to be closer to the size it should be relative to the meter stick in the camera view. So one trick that photographers use sometimes with the telephoto lens is there might be 5 people on a street, but if they use the telephoto lens, it kind of compresses the view. So it looks like it's kind of a crowded street instead of 5 people on a street. So use telephoto if possible. Then the next thing to think about from this is your shutter speed. And shutter speed, the guideline for videos to analyze is the higher the shutter speed, the better. The faster your shutter speed on an SLR, that would be how long the film is exposed. And so for a very short time of that exposure, you get much less motion blur. For example, a falling object, those things start going really fast once they've fallen not very far. We know this. They accelerate at approximately 10 meters per second every second. So they start going pretty fast, and you start getting a lot of motion blur. And that makes it really hard to tell where on the object you're supposed to click in order to track its motion. And it makes using the auto tracking next to impossible. So to change that, we change the shutter speed, and oh my goodness, look what happens as I change the shutter speed. I start getting darker. And this is where the lighting comes in. So I'm going to take this off the tripod and walk myself. Okay, so first of all, here I am next to bright light. But next thing, I'm going to go out the door. And if I go out the door and I change that shutter speed, then even with these much higher shutter speeds, it's still not bad. You can kind of see me. and then you can change the ISO of the film and change that a little bit to change how bright and dark it is. Oops, going the wrong direction here. I don't know what I'm doing. Oh, because my shutter speed is ridiculous here. There we go. So even with a shutter speed of 400, I can actually get really bright pictures if I've got a good ISO here. Most ISOs are going to be like in the 200 to 400 range. The lower the number you can get, the sharper your picture. The ISO is basically the camera, the film speed. Back in the day, you may have owned an SLR camera. You may have bought film that was ISO 100 or ISO 400 or whatever. Oh, sorry, getting loud out there with the trucks. So things to think about there. Other things to think about as you're doing this. Going to these settings. So this setting lets me change my resolution. Now, in addition to the shutter speed, changing the frame rate to a higher frame rate will also give you less motion blur. This also lets you view something in slow motion, but you can also change things like the resolution. 1080p is really high resolution. You may have a monitor that's a 1080p. You might have a 4K monitor. My camera, yes.
Can I interrupt for a second? So there was a question in chat specifically around resolution and whether 4K was necessary or 1080 would be fine, or what you'd recommend there.
I would say 4K is not necessary. I do most of mine in 1080p.
Perfect.
All right. So here is, I mean, we've got a whole bunch of camera settings here. And another thing to change again is the exposure, which will also do that brightness and darkness thing. That kind of automatically changes the ISO. But these are all settings that you can control to try to get the least motion blur and the brightest images that you can get with the best contrast. So those are the things that you want to think about with the camera settings. And there's probably multiple apps out there that do this. This one happens to be the one that we use. All right, last bit, editing. I'm going to stop sharing here and come back to my, well, I'm going to stop mirroring my phone anyway, and then come back to my screen. So let's get rid of this. All right. I use iMovie. You can use all sorts of different things for editing. I use iMovie, and basically the idea is you want to make this clip short because video takes up a lot of space, and taking up less space is good. So I make it short, I make it just the relevant motion, and I make it silent. So the first thing I'm going to do with this clip here is I'm going to get rid of the sound. Oops, that's stabilized. Here's the sound, and just delete that down to 0. All right. So the next thing I'm going to do is look at my video, and you can see I did this several times in this very room just this morning. And I don't want all of them, so I'm just going to scrub this. Until I just get that last one there. So right there's right before it comes into the screen. And then here is the last bit where I'm, setting it down and walking away. All right, that is the part that I want, just that part. And this has this weird slow-mo thing going on because I did it at 60 frames per second. I want to play it at normal. So now if I play this, oops, get back to the beginning. It looks normal. That's the whole clip. That's all I want. So nice and short, has just what I need in it. And then in iMovie, what I do here is share and file. So this turns it into a file that is the correct format for using in Vernier Video Analysis. It'll be a .mp4. High or best is fine. I think high is fine. I like better quality, but faster works as well. You can do whatever you want in here. Example, ball toss. And then it's going to ask me where I want to save this. I'll save it in my movies folder. And now it's saving. So it takes a little while to do that. I'm going to go ahead and stop sharing my screen. And I think it's time for Tom to take over. I hope I left you enough time, Tom.
Yeah, Fran, that was great. I learned a lot listening to that again. So, Fran, there was a question about, I think this was related to your editing software as to if you don't have access to that particular editing software, what options might you choose? I suggested using just the app on the phone, edit it directly on the phone before you email it. Other suggestions before I move on?
So if you're on a Windows machine, you can probably use something like Windows Movie Maker, or that may be an old name now. It might be called Windows something else these days. Been a while since I was a Windows user. There's a variety of online websites, but yeah, I just see a comment from Eric. Be careful with videos that come out in 8.heic format on an iPhone. That is the high efficiency format, and you don't want that. That's one thing I didn't show, but you can save that in your settings on your phone. Go to settings, go to camera, and then instead of choosing high efficiency, choose more compatible, or maybe it's most compatible. You want something that's more compatible with everything. And MP4 is going to be your best bet. Others may work, but we've gotten people calling us or chatting on our website saying, "Oh, I can't get the movie to work." It's just easier to just make sure it's a .mp4. Yeah,
if you can do that up front, it saves you a lot of trouble. You can reformat them if you end up with high efficiency format. It's just a little bit more work. Okay, well, I'm gonna jump in here and start sharing my screen to just walk through some basics of video analysis. Let me go ahead and remember how to share my screen. There we go. So the activity we're going to work on today is from our video analysis conservation laws activity book. And we thought it would be interesting to choose one of the videos that was related more towards, or one of the activities, excuse me, that was related towards sports physiology, and thinking that this would be a great way to engage students who may kind of be yawning when you're talking about pure physics related things, but they may relate a little bit better to something where it's involving a video of a friend jumping, for example. So that's what we're going to look at. It's called the analysis of jumping. So I'm gonna, there's two videos associated with this activity. One is called Jump Restricted, and the other is Jump Full. So Jump Restricted, let's just open that up. The idea behind this activity is that we're going to have these two videos, one where our model, Walter, is going to jump with his hands at his side. So here we see him jumping. We can watch that again, jumping. We're going to analyze that jump to try to pick out the maximum height that he jumped, the maximum velocity that he achieved in the process of jumping, and the acceleration, the peak acceleration that he achieved in that process, as a way of analyzing, you know, from a physiology standpoint, the leg strength of the person being videoed. In the next video that we'll watch, instead of having his arms at his side, he's going to be able to use his arms to engage in the full jump event. So it'll be a little bit different, a good contrast for physiologists, but also kind of interesting and engaging for students to think about, okay, what is really different here as we're engaging our arms in the process of jumping. How does that help? What is that going to do? Okay, so just kind of the basics of getting started with video analysis. First thing which I've already done is just to watch the video a couple of times. So we can see he crouches down, he jumps. You might note that when he's at the top of the jump, he actually brings his legs back up like so. So he kind of does a little, bring his legs in to try to maintain that maximum height as best he can. And you'll notice that there's a lot of extra, well, first of all, notice we're outside, so we have good light, even on a cloudy day. Actually, cloudy days are great for outdoor video because it's a diffuse light, shows up really well. We have in our frame, we have our 2 meter 2x4. We'll note that this is not exactly in the same frame as, or the same distance from the camera as Walter is. That's for safety reasons, obviously. We don't want him tripping over the 2x4 when he's jumping, but it does enter into some evaluations that you as a physics teacher might be interested in. Let's go back to the beginning here. I'm most interested in the jumping part, and maybe up to the point where he is actually starting to come back down. So we'll just kind of push this along until he's at the bottom of the crouch. We can see he's just starting to come back up here. So I might push this back just a frame or so. I'll get my fingers to work here. Okay. And then on this side, I'm probably somewhere in here. I'll just set it there and fine tune it here in a second. So if I play my video again, I don't need him to come all the way back down to the ground. So we'll elevate him maybe about right in there and just watch that. Yep, that's a good set of the video there. So that's all the portion of the video that I want to analyze, and I've just zeroed in on it here. Notice down here we have, you know, a fair number of frames that we're working with. Looks like from 192 on to 331. So there's quite a few frames. I don't want to mark every single frame, and the instructions in the lab might suggest that you advance this to 5 frames. So and just to show that again, I just clicked on this gear icon here, and it notes that the frame rate is 240 frames per second, which is the fast speed on an iPhone, or at least on my iPhone. And we can adjust the frame rate just by selecting one of those. So what this does is advances the video 5 frames each time we mark a point. Next thing I'm going to do is set up my system coordinates. So we get this, here is the scale. I'm just going to loosely put it in place here. Notice this is where we note that it's the scale. I can zoom in on this, and actually I did a pretty good job of setting that one This one I'm going to nudge a little bit further out so that it is as close as possible to the edges of the 2x4. And this is a 2 meter 2x4. So I'm going to come up here and mark 2 there. Next thing I'm going to do is set my origin. Origin is not incredibly important in this video, but I do want to make sure that, you know, my camera is a little bit cockeyed here. You can see my 2x4 is at a little bit of an angle. So I'm going to adjust that to line that up like so. And then I'm just going to move this to its heel. Again, the X and Y coordinate system is not, the origin of that is not critical in this evaluation. And we can zoom back out, and then I'm just about ready to start collecting data. Now, the physiologists are interested in that push of from the leg and how that affects his acceleration of his lower torso. I'm going to mark this. I want to find a distinguishing mark on the subject here, on Walter, that I'm going to be able to mark. It's not his center of mass, but it is, you know, basically his hip. So I'm going to mark that top of that third stripe throughout the video. And if I click, we see that it advances. That's actually advancing 5 frames. And I can just continue to click and mark. So you'll note down here, the frame rate says 207. The next time I click, it'll advance to 212. There it is. So this is the exciting part of the lab where you're clicking and marking. There is an auto track feature in video analysis, but unless you have a good target and a good contrast to work with, it doesn't work very well. And this would be a case where it wouldn't know exactly where on the stripe to mark. This could be a case where if you put a ping pong ball on a black piece of clothing or something like that, it might be a good tool for tracking that. Now I'm starting to see a little interference from the other marks. So I'm going to toggle off my trails so I can just focus on marking that point there. You can see we're at the top of the motion here, and Walter pulled his legs up. This wasn't anything he was coached on. He was just trying to jump as high as he could. This will be an interesting contrast when we go and take a look at the full jump where he used his arms as well. You can see now that we've gone through the entire range of the video we're interested in. I can toggle the trails back on to take a look at that motion. And here I have my X and Y coordinates of those data points. I'm going to change my view a little bit, and I'm going to toggle off the data table, and I'll just pull this over so I can look at my data a little bit more carefully. This is just like graphical analysis, so I can change. I'm really interested in only the Y portion. I just click on the Y axis. I toggle off the X direction, and I can see my motion here. So I can, you'll notice when here, let me make this a little bit more even. When I click anywhere on the graph, it goes to that portion there. If I click up here to, if I want to kind of move around, I just use this examine tool, click in the label down here, and now I can use the arrow buttons on my keyboard to move back and forth. I can pick off, you see these 2 points are the highest points at 1.2 meters. But my origin, I didn't start at 0, so that's not my change in position. overall. I can get to that by looking at my statistics. So here I have my delta Y is 0.622 meters. That's the total change in height of Walter's hip there. So that's a data point I want to take note of. I can also come here and notice that I have the ability to look at my Y velocity. It's automatically calculated from my position. And you can see there's a peak velocity of 2.43. Again, I'll just kind of move around here, 2.39, 2.43, and then he's slowing down as we have probably a little mismarking there on that one, but you can see he's dropping in this range here. It's kind of fun to see Walter flying like that too. Okay, so one of the things that's kind of cool to see here is this enable replay. So this just puts it here so you can watch the data stream in while you're watching the video. I can just return back here. I can slow this down significantly. So I can say, I just want 1/10 of the speed, and we can watch that happen. Data point by data point. Great. So that's useful to take a look at that. And then the lab would have us actually look at acceleration. So to get to acceleration, it's not an automatic calculated value. We're going to go back to our data table. We're going to click on the 3 dots next to the velocity in our Y velocity column and choose calculated column. I'm just going to label this Y acceleration, give it units of meters per second, hat squared. And my expression is first derivative. So, and it sets up, because I chose the Y velocity column, it automatically assumes that's what I'm interested in, Y velocity versus time, so I don't have to change those. If I had clicked on a different column, I'd be able to select Y velocity there. Same thing for time. Just hit apply. And now I have a column for my Y acceleration, and I can bring that value up here as well. Let's see here. Click out here and get rid of that. And we can look for that peak acceleration through here, somewhere around 12 to 13 meters per second squared. I'm realizing that we're right at our prescribed time. I'm going to, so the key points that I would pull off of this are my maximum Y velocity, my maximum Y acceleration, and that total range in Y for height jumped. And then I'm going to do that same analysis for the second video. And let me just pull that up to show it to you, and we'll providing you the tools so you can capture this on your own in the near future here. So I'm going to start a new experiment. I won't save this, and I'm going to import the second video, which is the full jump. And in this video, you'll see there's Walter using his arms. You might also note that he doesn't tend to pull his legs up. So that's going to change the final results of that. This would be a good point to have a discussion with your students on what is going to be different about his maximum velocity, about his maximum height, about his acceleration with this type of a jump versus that restricted jump. And have that discussion, have a little prediction go on there before they actually go through the process of analyzing that second video. I will point out that, I'm not sure that we've put this in the chat yet, so let me just show you this. Let's see. I know what I need to do. So if you wanted to play around with this, here is the key that you can use to activate video analysis for the next month and a half, basically until September 30th. I'll just put this code in the chat. If you go to videoanalysis.app, which is the chat app, or the app for video analysis, the URL for video analysis, and enter that code, that'll give you access to video analysis for the remainder of this month and all of next month. You can share that with your kids. I think rather than go through, since we were over time, rather than go through the analysis here, I'll leave that to you, but offer any help that you might need with that to contact Fran or myself, and we'll be glad to help you with that process. You have access to both videos and the access to the software and the handouts in the shared folder that we've provided for you. Any follow-up in chat we need to follow up on, Fran?
Yeah, there's several questions. So let me see if I can get all of them. If we have Logger Pro, do we gain anything from the video analysis app? So in addition to having auto tracking in video analysis, which is not available in Logger Pro, you also have the ability for students to use it on their Chromebooks, iPads, phones, whatever else. They may not have a Windows or Mac computer unless you issue those to students, in which case they do. There was a question about filming out and about in the real world. The main thing is the tricky thing is scale. So you need to make sure you know how big something is. Like if you film a car going by on a road, it would be useful to be able to look up the manufacturer's specification for how long that car is, so you have a scale to refer to. Can you add more than one video in the analysis? No, that's something that I will mention that to developers. I'm not sure that that is a feature that we would ever put in. And biceps curl lab, I believe we have that in the Vernier Video Analysis, Conservation Laws and Forces book.
If you, I kind of alluded to this in the video that we analyzed, you know, the scale 2-meter board is set back from Walter. And if you actually analyze the free fall acceleration of Walter, you'll find that he accelerates faster than 9.8 meters per second squared, which I think you can, to some degree, associate with the fact that the scale is makes Walter look bigger than he really is.
So where can I learn about this app versus the iOS app Video Physics? I don't think we have a point-by-point comparison on it, but one of the big differences is in video analysis, you can actually do the analysis, whereas in video physics, if you wanted to actually find the slope of a graph trace, you would have to export that data into another program, such as Logger Pro or graphical analysis. And then for physics of flight, that sounds awesome. I would go to the airport and find a windowsill facing outwards where you could rest the phone and collect videos, and then look up the manufacturer specifications on the airplanes to find out what their length is. That sounds awesome. And we've really gone over time here. You just built an airplane at your school. Oh my goodness. Well, you can just measure your airplane then.
Well,
anyway, I think we're going to have to go, but thank you all so much for coming. We really appreciate seeing you all, and all your enthusiasm and all your questions. We love getting all the questions, especially. You can ask us more questions on the chat on our website, email physics@vernier.com or email support@vernier.com, and they'll route it to us because we're the ones who know how to answer it. And you can also just call us up and ask for physics. Thanks for coming, everyone.